All right, well, good morning, everyone. Thank you for joining us for our Raeco webinar on designing a gas detection system. Kind of be walking through some of the basics, some of the things to consider and think about when you're putting a system in. Leading our webinar today is going to be Jim Behnke. Jim's had a long experience in the gas detection. Spent roughly 20 years with Honeywell and has been with Raeco here for a number of years as well. And I think some of his knowledge will be beneficial to everybody. So without further ado, I'm going to kick it over to Jim. Let him get us going here. And at the end of the session, we'll be doing questions as well through the little chat box at the bottom of the GoToMeeting box on the right-hand side of your screen. But in the meantime, I'm going to kick it over to Jim and let him do his thing.
Okay. Thanks, Tom. Again, this is designing a gas detection system, and we're just going to talk about some basic things to think about, kind of like 101 of gas detection system, not to get into too much detail, but to think about some of the major points that should be considered when putting together a gas detection system. What we're going to cover during this webinar will be understanding the application, identifying potential danger points, establishing design goals, determining gas characteristics, types of sensors to be used, profiling the plant and or facility or area where the gas detection is looking to be placed, other elements to think about, actual placement of gas detection sensors both indoor and outdoors, and maintenance and ownership of the system once it is installed. Why a gas detection system? Safeguard life and property. Typically, gas detection systems are built for safety purposes. We're looking to protect not only people, but also property and company assets. You need to provide early warning for hazardous conditions, provide an opportunity for evacuations should a detection level be reached, provide time for intervention and correction of the situation, have the proper types of protection systems in place such as ventilation, fire suppression. You want to also satisfy any local, state, or federal fire codes, provide insurability. Typically, insurance companies like to see gas detection equipment providing protection to the company's employees, address real and perceived safety concerns, and gas detection basic practices. Is it required by code or is it required by law? So understanding the application, you should become familiar with the types of terminologies that are being used in a gas detection system. The types of gases are toxic combustible. For toxic gas detection, there's STELs, TLVs, and TWAs. We're not going to delve deeply into this, but we're talking about short-term exposure limit for STEL, threshold limit value, TLV, time-weighted average, TWA. These are levels that are set by ACGIH governmental agencies that allow gas, basically it's how long people can work in a certain concentration of gas and still have no ill health effects being in there. So we're detecting levels that are below the STELs, TLVs, and TWAs. For combustible gases, we're in the LEL, or lower explosive limit, and UEL, upper exposure limits. Also, being aware and making sure that you kind of understand other properties of gases, such as the density, whether these gases are lighter than air and will float, are heavier than air and will sink. That will also help determine sensor placement within the facility. Also understand, and if there are any local and federal regulations, some towns do have it, some towns don't. Depending on where you are in the country, depends on what kind of regulations need to be followed. But the Uniform Fire Code and Code of Federal Regulations will give you good guidelines to use. You can also contact your local fire marshal, as your fire marshal will probably be by your facility anyway, providing audits, making sure you have fire extinguishers, those types of things, and they will be looking for gas detection should you have toxic and or combustible gases on site. So the three main types of gas hazards, again, flammable, toxics, and asphyxiants. Flammables have a risk of fire and or explosion. Those types of gases are methane, butane, and propane. Toxic gases, risk of poisoning and causing ill health effects to humans. Some of those gases that are commonly known out there are carbon monoxide, hydrogen sulfide, chlorine, ammonia. There's also asphyxiants. Typically, these are more inert type gases where they're not really toxic or not really combustible, but what they do is displace oxygen in areas where these, typically where they're stored. So nitrogen, helium, argon are very typical inert gases that will deplete oxygen. So here's some, I'm sure some people have seen this before, the fire triangle for combustible and flammable risks. You require a source of ignition, certain levels of oxygen, and a fuel for combustion to occur. When we talk about monitoring for combustible gases, we want to monitor below that flammable range where all the components are at the right levels and right mixtures where flame and or combustion can occur. So what in detecting these gases, again, we look at percent of the lower explosive limit. So we look for gases that are below that level so that we can determine when we're starting to get into a dangerous situation. So we want to catch these gases before they get into the flammable range. Toxic gases, again, are poisonous and can cause ill health effects to humans at very low concentrations. Some gases, such as H2S, ammonia, chlorine, have good properties for smell, but you don't want to rely on your senses as a gas detector, as sometimes these levels can be much higher than toxic levels that have been established by governmental agencies. Other gases, such as carbon monoxide, are odorless and colorless. You don't know they're there, but they can, again, be very dangerous, and they need to be monitored and detected. The levels that we are typically looking at for toxic gases are in parts per million. So on the slide here, it's depicting 1 million balls, and the one red ball would be considered as 1 part per million. So that, for example, ammonia has a threshold limit value or a toxic range for humans at 25 ppm. So typically low-level part per millions for some of these toxic gases is not very much, but can be very, can cause problems for humans. So you want to make sure that you understand that these gases are toxic at low-level concentrations. Asphyxiants, again, we're talking about gases that are inert and are typically not combustible or toxic, but again, cause problems because when leaks do occur, especially in storage areas or confined spaces, when people enter those areas, there may not be oxygen levels sufficient enough to be able to get in there and perform some work. Typically, ambient conditions of oxygen levels are 20.9%. Once you start falling below those levels, you start to get into a problem with being able to breathe. So you want to make sure that you monitor oxygen deficiency where areas where inert gases are being stored. Other characteristics about gases you also want to be aware of, such as vapor density. Again, we mentioned this a little bit earlier, how they behave once they are released into the atmosphere, whether they go rise, they're lighter than air or heavier than air, knowing that these gases will pool toward the ground or rise needs to be determined so that you can know where to place your sensors as well too. And again, toxicity versus flammability. The example here is ammonia at 25 ppm. Again, very, very small levels and become toxic. And CH4 is methane, and we again measure that in the 0 to 100% LEL. Some of the oddball gases that hydrolyze or will actually change once they hit ambient air conditions are gases like fluorine and boron trifluoride. What happens is once they are released into the atmosphere, they hydrolyze or will change into HF, hydrogen fluoride, and then you need to make sure that you're using hydrogen fluoride detectors to be able to monitor for these types of gases. Also be aware of flash points. We monitor a lot of solvents, and you need to be aware where that flash point is. The flash point, the easier it is to ignite the material, and that determines, again, the types of solvents or compounds that you have. Also keep in mind rate of evaporation, dispersion characteristics. Will this stuff go away quickly? Does it hang out? And then again, keeping in mind the fire triangle, you need to have the proper amounts of fuel, oxygen, and an ignition source. Again, monitoring at below % lower explosive limits. And then again, inert gases, oxygen depletion. What you want to do also is do a walkthrough, go through your facility and identify how your plant is set up, what kind of ventilation is going on for indoors, make sure that there's escape routes that are available if gas detection is sensed. You need to protect areas and entrance to areas that have these toxic and or combustible gases going into them, mark escape routes, and be aware of outdoor wind directions as well. So where do we place these sensors? Well, we need to start thinking about where the problems could occur at a facility. So we're looking at areas that have seals, flanges, pumps, welds, expansion joints. Those are typical leak detection, or those are typical areas where gases can get released. Failures to those types of places would cause leaks. We're looking at storage areas, loading, unloading areas, runoff areas for major spills, and decomposing materials from methane releases. You also need to be aware of what's going to happen around you once these detections get released, specifically outdoors, what the wind direction is, indoors, again, ventilation system, confined spaces, what's around your facility. Do you have communities or your neighbors, other manufacturing sites? You don't want to make sure that you don't send gases off into those other areas. Once a gas detection lease is happening and sensed, you need to start to think about what kind of actions are going to take place, or what do you want to have done to make people aware of what's going on. How do you want to get rid of these gases? Do you want to initiate some ventilation control? Do you want to shut down your processes? Those are the kinds of things that you need to think about what to do once a gas detection release has occurred. So it's always good to have enunciation around, and then any types of litigation of the gases and to help ventilate or to help alleviate what the situation is. Having response teams ready to go. How are you going to get this stuff under control? How are you going to clean it up? Do you need to get suited up into SCBA equipment? So knowing what kinds of compounds and gases that you have on site is critical to how you're going to react and control and determine what you're going to do once gas detection is sensed. Determining what kind of sensors to use is also critical, as these technologies all have their limitations as well too. So we're not going to get deeply into these technologies, but just things to think about. Electrochemical cells, some gases can tend to interfere, so you need to be aware of other compounds that are on your site as well too, so that you don't run into false positive alarms. Catalytic bead sensors, again, used for combustible gas detection. They require oxygen to work, so you need to make sure that they're in an oxygen environment. Photoionization, typically for volatile organic compounds. Again, this is more of a survey type, handheld portable unit. Infrared technology can be used for both toxic and combustible gases, and there's different types of infrared technology. Depending on how specific you want to get, and to be able to eliminate other unknowns or other cross-interferent gases. Also need to be aware that some gases do not absorb infrared energy. Diatomic compounds such as hydrogen, chlorine, bromine are gases that will not absorb infrared energy, hence you cannot use that type of technology to detect for them. Other things to think about, you want to keep these detectors accessible for maintenance and calibration. Make sure you have the proper wiring and conduit runs, whether you require rigid pipe or cable tray. Keeping, again, aware of environmental conditions, prevailing winds for outdoor applications. Some equipment in facilities emit electromagnetic interference. You need to be aware of that if you have that kind of equipment. Radio frequency, walkie-talkies could sometimes cause a little havoc if proper shielding is not provided. You need to be aware of where you want to set alarm levels. You don't want alarm levels too low or too high. Typically, safety people will help with those kinds of decisions to be made. Oxygen levels, again, electrochemical sensors require some oxygen to function properly, as well as catalytic bead. And then also be aware of poisoning. Overexposure to target gases could possibly tend to dry up the electrolyte in an electrochemical cell, or silicones would tend to coat a bead on a catalytic bead sensor, rendering it useless until it is checked with some calibration gas to make sure that it is still responding properly. So being aware of other types of compounds that are in your facility is key as well. Placement of sensors, again, we talked about it a little bit. We'll talk about it again, but UL suggests a 900-foot square ceiling space for smoke detectors. So smoke detectors have a kind of a general guideline. There really isn't anything that I'm aware of besides some general recommendations where to place sensors. Again, there's a couple of schools of thought on this, whether you want to protect people more or protect equipment. Keeping sensors located where people are working is always a good idea, and also locating sensors close to possible leak points. Again, we'll talk a little bit more about detector placement. You want to make sure that you keep these things away from water, moisture, dust. Try to minimize exposures to these elements. Locating detectors with respect to grade, we talked about gases that rise and fall. You need to determining where to place those. Monitoring equipment, again, near pumps, valves, seals, that's always a good idea. Sensitivity of your detectors, again, depends upon how close you get these things to potential leak sources. So you want to be aware of that. Keep them away from vibration, and we've also seen that some detectors, you need to protect them from forklifts and lift trucks. You don't want people running into these things as well too. It's always a good idea, if you're not sure what to do and you're not sure of what your dynamics are like, can also conduct some smoke tests by just releasing smoke and seeing exactly where all your wind currents are and how your ventilation is moving. Outdoor locations, same considerations, but again, you need to consider prevailing winds. Wind doesn't blow in the same direction all the time, but there is typically a prevailing wind direction. Other types of structures and how your facility is put together, whether you have stacks, large buildings, small buildings, those types of things. The proximity of large quantities of combustible or toxic gases. Do you have large storage bins, large storage tanks? We're going to talk about open path versus point infrared detection in a minute. Also be aware of places where gases can pool into low-lying areas and confined space. Also be aware of ignition sources that may be downwind. You need to be aware that if combustible gases can get down into those ignition sources with the right percentages of everything, combustion fire could occur as well. Again, point versus open path infrared detection. Open path detection is more like perimeter or fence line monitoring versus point detection, infrared again as well, getting close to actual release points. It's very, very common to have a hybrid type system where you integrate both point detection and open path all in one for proper gas detection coverage. This is typical in combustible gas situations. Other general conditions to consider, always, use the manufacturer's temperatures and ratings. You don't want to go into high heat areas when you have detection equipment that's rated for 105 degrees F. Keep detectors, again, away from moisture and chemicals and spills, away from vibration, mechanical shock, people running into them. Make sure you use proper cabling. It's very common to use shielded cable. It is recommended to use shielded cabling for your gas detection and proper grounding practices that are typical electrical code standards. Also, observe proper orientation. Again, manufacturers suggest how to locate these things and how to orient them. Typically with electrochemical cells, the cell is facing downward so nothing gets caught on the top of the sensor. You want to keep them clean. Same with infrared point sensors as well too. Follow manufacturer guidelines. So once you got everything up and running, it's very critical and it's very important that somebody actually takes ownership of the gas detection itself. Gas detection is only as good as it is maintained, and gas detection systems require maintenance. How much? It depends on the system. How often they need to be calibrated depends upon the technology that's being used, but those things need to be considered, and somebody really needs to take ownership of the gas detection system once it's in place. Functional testing should be done at startup, making sure that all the proper signals and shutdowns, enunciations, all are happening when you think they're going to happen, and they're happening in the sequence that you want them to happen. So that can get very, very complex. Again, we're not going to go into that, but it's something that you need to be aware of, make sure of, and test for it. The last few slides here, we'll just look at some typical installations on an outdoor applications. You see point detection here on some storage bins. The next slide here also incorporates some infrared open path detection as well too. So we're enhancing not only the sources but also the area around. So you can cover a larger area, but again, you're just looking for more gross releases with open path. Again, just some more applications of using a hybrid type system. We're using both open path and point detection. We run a number of loading and unloading facilities. This is typically rail car. We see that on tankers as well too, in terminals. So you can, again, enhancing your point detection with open path, encompassing the area and or fence line. These are some other publications that can be referenced that would help guide you in putting together a gas detection system. So there is other places that you can go to and other governmental agencies that do talk about gas detection systems. That's what I have for now. If you have any questions, Tom will take a look and see what we've got here.
Yeah, if you have anything specific, go ahead and use the chat box on the right and type in anything you want.
While we're waiting for questions, this presentation will be on the new Raeco website. If you get a chance, please take a look. Once you get onto the homepage at Raeco.com, we have a training center. You can click on the training center, and then at the training center, there's another tab for webinars. We have a number of webinars up there already. This one will be posted shortly as well. Okay, well, it looks like I did something right. In fact, no questions have come in yet. I hope that this was informative and helpful to everyone that joined us today. Appreciate you taking time out of your day to visit our Raeco webinar. Again, check our website, and appreciate everybody's time.
Thanks so much, everyone. Have a great day.